Alright, in this video I'll be going over the last two pages of the review for test 3. So let's go ahead and get started. So here we're just filling in terms, definitions. So a poll of 1,500 registered voters in Texas was taken to determine who they favored in the last presidential election. Excuse me. So in statistics, these 1,500 voters are referred to, you should have said the sample, and all registered voters in Texas are referred to as the population. So basically, this is a subset of the whole population, and it's used for us to make some prediction about the whole population. So the sample is always smaller than the actual population. In this case, that would be all registered voters in Texas. This sample is considered representative if it is a small replica of the entire population with regard to income, education, gender, race, religion, political affiliation, etc. In other words, it looks like the population. You can't just, like pick voters in one city because that city is probably different than the overall makeup of the whole state. So you're looking to make your sample as representative of the population as possible so you get an accurate result. The sample is considered random if it's obtained in such a way that every item or person in the population has an equal chance of being selected. So there's ways to select people from the population randomly. You can do that with a computer program. Even calculators do that. In D, descriptive statistics is the branch of statistics concerned with collecting, organizing, summarizing, and presenting data. Inferential statistics is the branch of statistics that involves making generalizations about and drawing conclusions from collected data. So descriptive is the part where you're just kind of putting it all together, but inferential is what really matters to people, because once you've collected all this data, you want to see if it's telling you something, if you can learn something from the data, if you can infer something from the data. The range and the standard deviation are measures of dispersion, which really tells you how spread out your data is. We also talked about measures of central tendency, what's going on in the middle, what's average. That was mean, median, mode, and mid-range. All right, number 32. Let me move this a little bit. So use the frequency distribution for student scores on a math test to find the following. The total number of observations. Well, you're going to want to add the frequencies. When you do that, you get 25. The width of each class. Well, you just subtract two consecutive lower class limits. And in this case, that would be 10. Notice you could also use the upper limits. The lower class limit for the first class, that would be 40. The upper class limit for the second class, well, that would be 59. All right, so students had the following scores on an English quiz. Find the mean, median, mode, mid-range, and range. Excuse me. So I already put these in order. I'm going to go ahead and write them out in order. So basically what I do is I go through this list and I go from lowest to highest, and I'll cross numbers off as I use them. But you would end up with 2, 3, 2 4s, 2 5s, 2 6s, 2 7s, 4 8s, 2 9s, and a 10. So the median turns out to be the 7 here. Notice if you did it correctly, you should have the same amount of numbers on each side. We have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So there's 17 pieces of data, and the one in the middle is 7. So that's your median. If you add all these up and divide by 17, you should get a mean of 6.4. Of course, the mode is the one that occurs the most frequently. That's going to be 8. The mid-range will take the highest value, 10, and the 2. And if you take 10 and 2, add them together and divide by 2, that's how we find the average of those two numbers, or the mean. So that would be 6. And finally, the range. Remember, the range is actually a measure of how spread out the data is. Here you do 10 minus 2, and you would get 8. So make sure you know how to find each of those measures. Let's move on to the next page. I'm going to move this back a little bit. Alright, the following list gives the sales price for 6 homes that recently sold in a neighborhood. Find the mean and median price of the homes and determine which measure is a better measure of central tendency in this case. To save some time, I'm just going to go ahead and put up my answer here. I hope that you've already tried to do this one so that you can just be checking yourself. So the mean, you should have added the 6 numbers up and divided by 6, and you should get $185,333.33, rounding to the nearest penny. The median, well, if you put these numbers in order, the two middle numbers are the 195,000 and 205,000. If you average those or find the mean, you get 200,000. So that's your median. Notice it says the median is better because it's not affected by the outlier. This 90,000 is a lot less than all the other values, and so it has a way of bringing down the mean, whereas with the median you don't have that issue. And so in this case, that outlier, 90,000, causes the mean to be lower than it should be. Kind of throws it off. So the median is the better choice. All right, let's go ahead and look at the next problem. So here you had to find the mean and the median. And so I'm going to go ahead and put up my work. So first of all, to find the mean, you take the sum of the xf's. That's basically x times f. So here's your xf's. The first one is 1 times 2, then 2 times 2, then 3 times 3. So basically, instead of writing 2 1s, we say 2 times 1. Or let's go down here. Instead of writing 6 5s, we'll say 6 times 5. And so it just makes things a little bit easier, quicker. So you should get 467 when you sum your xf's, and you'll divide by n, which is the number of pieces of data. So here you had to add frequencies to get your n, which is 71. So when you divide, you get 6.58. So that's your mean. We learned that the middle value can be found using this positional value formula. It's n plus 1 over 2. In our problem, n is 71. 71 plus 1 divided by 2 is 72 over 2, or 36. It's 36th position. So what does that mean? The number that is in the 36th position is your median. Now notice the data is in order here. So you have two numbers here. So the second number is a 1, right? You have two 1s. And then you have two 2s. So that last 2 would be your fourth number. You just add 2 plus 2. And now there's three numbers, or three 3s. And so if you add 4 and 3, that last 3 will be the seventh number. And we'll do this one more time. You have 5 4s. So the last 3 was the seventh number. You add 5 4s. The last 5 is your 12th number. So you just keep adding these numbers. Notice you're up to the 45th number here. And here you are at the 30th number. So that means that your median must be a 7. It's one of these 15 sevens. All right. And then a last problem. Again, I'm just going to put up my answer here. So the first thing you do is you find the mean. It's also good to know that n is 6. That's the number of pieces of data. You make this chart. And so you put your data here. You take each of your data values and subtract the mean, which was 12. You get these numbers here. And then in this last column, you square these numbers, and you get what's here. The next step, and these are all according to the steps that are given on your formula sheet. You add up these numbers, you get 80. And then you're supposed to divide that number by n minus 1. In this case, n is 6. So 80 divided 5, you get 16. Last step is to take the square root of this number, and you get 4. So basically what this is saying, we're supposed to explain the meaning, is on average, the data is about 4 away from the mean. Well, that seems reasonable because notice 7 is 5 below the mean, 9 is 3 below the mean, 11 is 1 below the mean, 15 is 3 above, and 18 is 6 above. Notice the mean, 12 is 0 above the mean. So on average, you can see you're about 4 away from the mean, and so that's what the standard deviation is telling you. All right, that's it for the review.